The ocean is an invaluable gift from Allah the Almighty. The ocean provides the necessities for humanity. The problem is that our ocean is currently facing various very serious problems. One such issue is microplastic pollution, which impacts the environments and the marine organisms.
Microplastics. What are they? They are a solid, plastic-like pollutants measuring less than 5 millimeters. They are a significant national and also a global concern. These microscopic particles have entered the ecosystem and have serious impacts on the surrounding environment and also on living organisms. Given this problem, a solution is urgently needed to reduce the presence of microplastic in the surrounding aquatic environment. The solution we offer is seawater filtration to trap microplastics, thereby reducing their numbers. One material that can be used as a filter is broken coral skeletons. This is the first prototype of the many microplastic biofilter. This prototype is designed with a circulation system and reverse gravity to enhance the effectiveness of the plastic filtration process.
Conducted observation to determine the amount of microplastic in seawater samples and the result of filtration using a microplastic biofilter. We filtered 50 liters of seawater samples using a plankton net 3 times, and another 50 liters of seawater samples were filtered 3 times using a microplastic biofilter. The seawater samples and the filtered seawater samples were taken to the laboratory to observe the microplastic levels.
Observe microplastic in filtered seawater samples. A KOH solution was used to remove organic materials. The KOH treated water samples were left to stand for 24 hours. After 24 hours, the water samples were filtered using a GFF filter. The filtered samples were dried in an oven at 60 degrees Celsius for around 1 to 2 hours until the filter was completely dry. Filtered samples were then diluted with distilled water and observed under a microscope at 100 times magnification. The amount of microplastic present was then analyzed to determine.
Our research found 70 microplastic particles per liter of seawater in Kendari Bay, Southeast Sulawesi Province, with a consisting of 31 fiber particles per liter, 15 fragments per liter, and 23 filament particles per liter. Using a microplastic biofilter, reduced the number of microplastic particles to a total of 18 particles per liter, with a consisting of 7 fiber particles per liter, 5 fragments per liter, and 6 filament particles per liter. The use of microplastic biofilter can remove up to 79% of microplastic particles from seawater. Our research revealed that the most abundant type of microplastic filtered was fiber. Microplastic fiber are thin thread-like plastic particles measuring less than 5 millimeters.
In conclusion, microplastic biofilters can be used to reduce the amount of microplastics in the surrounding aquatic environment. Our microplastic biofilter can remove up to 79% of the microplastic particles in the seawater.
Microplastic biofilters are the world solution.